Bismillahirrahmanirrahim. Assalamu alaikum everyone and good morning to all. Uh, Welcome to this session. Today's topic is artificial neural network presented by Mr. Rahman. Well, uh, in this session, I will try to cover the introduction of artificial neural network and its architecture, and we will show the mathematical analysis how the ANN represent in matrix and geometrical equation, and finally we will show a simple code of ANN with a dataset, tabular dataset. Let's start. So where comes from the ANN? Well, it's refer to a biological inspired by human field. The ANN is goal to develop something that human can talk. So inspired them as the we know that the human brain are consist of a number of neurons. So before 20 years ago, this was very difficult to imagine that one day a will perform as like human. So also we can call that the ANN is the very basic background start from this today's revolution of the LLM model or GenAI model. So you can see that picture that here compared a human neuron with the artificial neuron, and later slide will let's see. So here is the comparison between actual human neuron and the artificial neuron. We can see that the dendrite is compared to the input. So whenever we pass just for simple understanding, pass a data set, this all are the our feature as like input. So in the it compared to the human neural network as dendrite, and which are compared to synapse and output. So we will not much talk about the human neural network as today's topic is not. But as the ANN is inspired by this, that's why I mentioned it in this session. Uh, okay, now look about the architecture. Don't worry about this. The architecture. This is one of the typical architecture of ANN. So basically it's look like this. If you look at my cursor, that the input, this is the input and this is not a neuron. Basically this is the placeholder, and this is the output layer. Between these two layer, all layers are called that the hidden layer, and whenever data pass through input to output, it called forward propagation. Basically it happened every deep learning model or whatever you say. And the back propagation on the other hand, whenever we return output to input, we think whenever the model rise to overfitting, we want to reduce this. That's why back propagation here. uh, we will also show a clear architecture of the artificial neural network. Well, so as I already told that the between hidden layer is lies in between the input and output layer. So there is no fixed definition or fixed number the neuron of hidden layer. We can see that that each input are strongly connected with the hidden layer, and this is the first hidden layer and the second hidden layer. We also see there is a clear difference between first and second hidden layer is that the first hidden layer less neuron compared to the second hidden layer. uh, According to our developed model, we can fix the number as required to our the data set, and in the output feature also depend on the our goal. Like here we can see the uh, two nodes in the output. That means that it's a, we can say, binary classification. Just consider that 0 or 1 it can return. So here I also mentioned it, visualize gif about ANN. like actually what happened in our real life. If in our data set consider two images that are dog and cat, so whenever we pass a image, it actually split it into the number of input features and then it throws the hidden layer. For simple understand, just mentioned one hidden layer, it can be more than one and the node number also not fixed. So this is just an example. So image, we can see that how pass there, and finally we find a output. So mm, sorry for that. This is the neural network view. Basically the as I already mentioned it, that artificial neural network is inspired by human brain, and it start from the perceptron. There also feed forward network look like how today's ANN architecture or already have. Not all we are used directly, but we use it some subset of other big model. Among them, I want to, you already maybe know that the attention neural network. So this is the core part of transformation, and we know that in 2017 Google released a paper which called it Attention All You Need, where we can see that the transformer, or from this paper actual the revelation of typical deep learning to generative AI, and how looks like this model. You can look at this picture. Uh, and now I'm talk about the how mathematical we represent our artificial neural network. So I'm opening a slide. Okay, so this is the very basic equation. We all know that the line equation, and what does it means, the where m is slope and c is the um, coefficient point. So just consider if the c is equal to 0, the line start from the center point. So we will develop our today's ANN model from this equation. So compared to this, um, our model called look like this equation, and this is b means bias, and weights represent W, and X represent input, and O for output. So weights is nothing, just a 2D matrix. I will also tell more about this. Just if we consider these both equation are similar, the just different is the character. So keep on mind, and I will start here. So typically how look like a neuron. Basically, if we consider just a node, so what is the it inside the path? Well, each node had two part. First part is it summation, linear linearly calculate the summation of all input, and then after calculate the all input, it pass through a activation function, and activation function will return a output. And there are different activation function available, like among them sigmoid and relu are two famous. uh, just very basic activation. So what does actual activation function do? Well, as we can see, look at this, there are consider there are a lot of neuron available. So which neuron will each neuron has as two part, like outside the inside, the input and output. So whenever we pass the input, is the neuron is active or not, it depend on the activation function. So that's simple for understanding that it pass that active or inactive node. So after this we pass the output of this node is input of the hidden layer, and it output will pass through activation function. Maybe I make it more complicated. I will also try to uh, easy understand say. Uh, okay, so let's talk. This is our a tabular data. In the machine learning, we all work about a lot of .csv file data, where we can see that the data set are according to different feature this all look like, and where is the one target. So think about this. I have here 10 rows and 3 features. So I can write look like this, and this is my target value. So okay, I do not already mention about you that maybe you already know this is the input layer, this is the hidden layer, and between the connection line between input and output, we can see there is a connection line. Each line has a value, the value like one. It's called weights. So weights can be different. Basically in model we can see that weights is point 1 to 0 to point 1. So for simple understand, I just put, or it can be negative or positive, any value. Weights can be any value. For our simple understanding, I just put 1 2, and I just simply are okay, 3 4 5 6. This is called the weight. And in our model, if we recall that I, so here x represent this input and weight are this thing. Each line has each value, and this is called the weight. And here this is bias. Also bias we add, also consider this is 0. So our equation is look like this. So what is more? We already say that weight is nothing, just consider a 2D matrix here. And okay, before I talk about this, I want to mention one thing about the matrix multiplication. Matrix, like if I have a matrix, matrix size is like this, and the B matrix is 4 into 3. So uh, if we want to multiplication these two, there is no possible, because I just, and simple and straightforward rule is that the first matrix column is similar to, must be same to the second matrix row. Here we can see the difference, so we cannot multiply this matrix. But if like this we can easily multiplication a into c. So okay, why I mentioned this thing? Well, so I just clear this thing. So okay, so this is the our data set which has 10 rows and 3 feature. So if I fit into this equation, like I know the input shape is this, so I just mentioned it this 3. And so how many weight are I need, or what will be the shape of the weight matrix? We can simply, as we want to multiplication with this side, so definitely this column will be just mentioned 1 into 10. I just put any value we can here. So our goal is as the final layer is 1 1. So how do I reach 1 1 through this architecture with help of this data set? So we see that here is the, we can just mention that 3, we can see that there is a 3 node, here is 2 node, and how actually we layer by layer the size reduce, and finally we will find the output. So this is our goal. So if I multiplication with this, I just again tell you that this is the input shape I found from this data set. I just assume this is my data set, and I put this, this is weight matrix W, and this is X. So if I multiply this, I will find this shape. So I know, I assume you know that how to find the shape of matrix. So 1 3, but our goal is 1 1. So how do I find this? Well, if you think, or if you consider that if I reduce the size of data set, like I do not pass entire data, I just slice just one row and three picture. If I pass this like, okay, I have to clear something. Okay, so this is my feature I will exactly pass here. So if I pass this data shape here, then what I will find actually? Well, so right now my matrix shape is mm, what I say. Okay, I have to rewrite the equation for better understanding. And so why I pass one? I just consider the first row only, and here is three feature. So this is right now my input shape. So what will be the weight matrix? We know we want to something like, okay, this color is not much visible. One into we can put also one, that just try to similar this number. So if we multiply this, we will find also again 1 into 3. But our goal is to find 1 into 1. So how do I find this? Still now I am not reach out. I tried a full data set. Also on the other hand, I pass a slice of data set, but I am not able to find. So what I will do? So I am sure that if I use this equation, I will not find it. It will. So what do I need here? Change the simply I transpose the input shape and then it. Okay, so if I transpose it, as I pass here 1 into 3, it goes to 3 into 1. And what will be the weight shape? We know that something 1 into 3 will be the weight shape. So if we multiply this, we will find 1 into 1. We will reach our desired output. So so far, have you any question about this thing? Okay, I assume. Okay, move forward. Just keep in mind this is our tabular data. So okay, we will see that the matrix representation this thing. But what about if we want to do in the equation? Uh, how it equation part? Okay, I will draw again. Okay, just 1 minute. I clear the whole thing. Okay, so I want to draw again this input shape again. Just wait a minute. So if I put there the weight are like W1, W2, weight 3, weight 4, and so on. I just consider this node also, and we know that each node inside has two part. One is the linear, and another is the activation for non-linear part. So uh, so we want to find this output. So how will the general math or geometric lies here? Well, so we see that here come in three input like x1, x2, and x3. All are the incoming three input from the like look like three feature, and I also add their weight respectively. So the first one weight is, and this is the w3 weight, and randomly this is 6. So we know that x equal to, like just compare z equal to the linear summation part is this. So we already before see the matrix. Whenever it goes to deeper the or more node here, so we cannot actually calculate easily. That's why we convert this into the matrix representation. And if we see that this is the our linear part or first part of the activation function, and after that we will find a result like z1. So just consider our activation function is sigmoid, so we must be pass this value in the sigmoid, and it will give me a result. So I just call it the one a1. So the superscript here, it means that the number of layer. So this is the first hidden layer, so the output will be a1. and this is in the subscript it mentioned the number of node, like we can represent this a21. The superscript is the similar, but the subscript is changed. So we can represent this general geometric. So after that we will find like how many z will be find z1 2 3. We will find z1 z2 and z3, and then uh, each time it calculate like this also incoming three features. So similarly if we add this we will also find then uh, this is like second layer output. So basically this is the way we can represent it. So that's all about the basic math intuition of the ANN, how we drive it from the linear equation to line equation to the this format. I just wrote again. So this was about like this, and the output. So we ignore this term here, it is called bias, so ignoring this, and this is in the ANN, the things are called weight matrix, and this is our input feature, and finally we see just transport the input value. So most of the equation in any article you will see they use, or book they use this. So we already see why we must transport the input feature. If we do not, we will not find the feature similarly. So that's all about basic mathematical intuition of ANN. Now I am moving to code part of the ANN. So where I do this, okay, here. Well, so this is the Google Colab platform. I hope you all are familiar with this. And first of all, I assign some basic thing library. and this is our data set heart disease. So how looks like the data set about, this is our data set which is almost 14 column, or you can say features. Among them, one is our target or output, and it has 303 rows. And we see here that the summation of our data, so it returns that there is no null value. Is null, which return is inside the data set, is there any value null or not. So I can see that the my data set there has no null value. And if I want to know the information about the data set, I just call this diff.info, so which represent what type of data. So I see that the data type of this feature are maximum are integer, and one is floating value. So I just shuffle this data set. If you look at this, that if I do not shuffle, so the first some data we see that represent 1 and other represent 0, so there might be a error. So tabular data we must be shuffle it for better output. So I can see that there is some 0 coming here and it shuffle. And the I just divided x and y for input and output target value, and later on the normalization. So whenever we want to do any deep learning code, ANN also is the basic of deep learning. uh, we can also say that the start deep learning actually from here. So if we do not normalize the data set, so the value might be high or it goes error. We do not find the crucial output. That's why we normalize, and whenever we want to normalize, we see the data range between 0 to 1. So we can if we look at this output matrix, you will saw that. And one thing, remember that we normalize just the feature input, never in the output or target value. And this is the very common train test split for the machine learning. How do we train and split a data set? So well, here is our neural network could basically start from this. Above the all are we see in the machine learning. And I import our model from the Keras. So with help of Keras, I built my ANN model. So what is Keras? I know you have much idea about this. If you not just search on the online, you will know. So Keras has many built-in library. Among them, we just import which one is our necessary. So why I first of all I insert the sequential, then I dance and drop. Well, I want to talk about this a little about. So if we look at this architecture, so just ignore the other word. So if you look at this architecture, you see that this is a layer, this is layer, and this is. So in our real life model, it can be much more, or we also add any number of hidden layer, whatever we want, or for desire our output. So and also you look that this is a sequence, because without input layer we cannot deep dive into the hidden layer. So one after one, that's why we need the sequential. And here you also see that the just I want to see the dance. So what does it means? Nothing that it does, it simply means the number of node. So whenever we want to how many node inside each hidden layer, we just put it as a dense layer. So uh, that's it about dense. And the dropout is nothing about how many, whenever we run this model in our that whenever run a deep learning model, we see that the models is overfitting. It's perform well about the training data. Whenever we insert a new data, we see the accuracy is like consider 60% or 70%. That means that our model is overfitting. So to reduce the overfit, we want to discard some data from the data set. That's why we use dropout. And here I assign the a variable classifier is sequential, and as I mentioned, this is the very simple. That's why I just want an one dense layer add. So number of hidden node is 10, and as a activation function I use relu and input dimension. So this is the important thing is that whenever we do code in any deep learning, we must be know all term. We have to familiar with this. And in our machine learning, we just fit test, y test and x test. We never bother about the input shape. But whenever in terms of deep learning, we must be specify that the input shape. So where I find this the input shape here is total 14 columns and one is target. So we know that 13 are feature. That's why I written 13 here. So it the value will be changed according to data set, and how much I want to drop out when the learning. I just assign 0 0.1. Basically, I might be wrong. Basically, it point to, or if the data set has very large, like it data set consists 1 lakh or 2 lakh value, we can use point 3 or above point 0.5, and so many. And then finally I add denser one. This is the we can say that final output. And this is the compile model. uh, and in the compiler I use as a optimizer. uh, Actually, what does the optimizer do? Okay, I will talk about it. And again, in here loss binary cross entropy. So binary cross entropy return two value, either 0 or 1. As my data set, the target value is only 2, either it return a value 1 or 0. That's why I use binary cross entropy. If in your data set has more than two output value, like you want to print 0 1 2 3, so you must be use categorical cross entropy. And during the compile model, I noticed the accuracy. So whenever in the output log we see that the accuracy sometimes drop and sometimes rise. So because of I am following the accuracy measure, we can also here validation loss or loss we can pass. And now it's the fit model. So I already mentioned that in machine learning we just fit the model like x train and y train, and we never pass any batch number, batch size or epoch. In the deep learning we must be assigned this. So what is the batch size and epoch? Epoch is nothing, just like a loop, or we can say for loop in our general programming language. And what size the batch size? So well, I talk about a little this. Batch size means 32. So like my data set has 100 features or 100 rows, and if I assign batch size 32, so if I divided this, I will be fine 3 point something, just consider 3. So each loop, the 32 rows togetherly pass, and each inside each loop it will be pass 3 times data. So we can also increase the batch size or reduce the batch size depending on look at the output logs. And Uh, well, I hope the screen is visible now. Sorry for the interrupt. So after run the model, now I want to print the summary of my model. As this is a very basic model, so I can see that there is only two dense layer, and as one is and dropout layer, and we also see that the total trainable parameters and non-trainable parameter, uh, and we find that our the accuracy, so 85, not I can say good but not much good. We can change the bed size or activation function, it will be different, and then I will draw the confusion matrix. So here we know that the 1 1 represent true negative and this is the true positive, and the correctly model predicted this. I see that there is a less error. So well, I ran again this model with inside you. I just disconnected the runtime. Okay, and at this time I set like what I want to change. Okay, I just change the batch size 64, and the epoch will be set 150, and let's see what will be the output. Okay, this is the one thing very disadvantage in Google Colab is that whenever we restart the okay, take few time. Well, okay. So I upload the dataset. Whenever we refresh, the dataset is gone. So I just load my dataset here, and I run, and I want to see that what will be the output change. Just one thing, remember that right now we have 85. I'm pretty sure that it will be changed. Okay, it not take much time. Uh, well, it start working. Alhamdulillah. Okay. Okay. Whenever we run any deep learning model or any ANN, we can see that the approach how. But I also ignoring the what I say early stopping and checkpoint just for simple understanding this. So we see that it take very less time and it 1,500 epoch done. And what will be the output? Wow, congratulations, the output will be rise 86. So that's all about this code. And once again, if you have any particular question regarding this code, feel free to ask me. I will try my best. Okay, so one thing is that I ignore during the presentation, that is what I say, that is called optimizer. So basically what optimizer do, or why need we optimizer? Well, so just for understanding, we output find 86. Okay, so after okay, just consider the loss value. Okay, so as a whenever we want to learn any deep learning model, we try to minimize the loss. So just simple understanding, we first of find loss 2.5, and then we find loss 2. After another trend, we find the total loss is 1.5, and we know that how to calculate loss, or what does loss mean. The loss means is that simply if I say that the difference between actual one and predicted one, like this is our actual value and this is our predicted value. So how much correct my model, it's defined on the loss. So the less loss is means the more efficient model. So what does it do here? Okay, I just back to my slide. draw it takes few time. So we know that each connection between has a weight. So during the back propagation, so we update the weight. So what does the optimizer do here? Optimizer actually update the weight. So how much update the weight, it depend on we know that there are different optimizer. Among them, the first one and very popular one is the gradient descent. So like this, my weight is currently 2, so I find 1.5. So if I update this like 1.5, or if I increase this 2.1, maybe the loss is reduced to 1. So optimizer helped me to reduce the update the weight. And just I show here that how weight update. So if we consider this is our new weight, and this is our old weight difference, the partial derivative of the loss with respect to weight. So this way we can optimize the weight. Similarly, in the bias term, so I ignore the bias for simple understanding the model. So we whenever you see any model, we can see that they are add a additionally bias. So I just ignore it. So that's all about today's uh, presentation.